So just like we have properties in algebra and geometry, we have some identities in trigonometry. So identities that are true for all values of theta. So no matter what my angle is, some I guess rules that are always work. So a trigonometric identity is a trigonometric equation. Equation that is true for all values of theta. And these are just rules to live by when it comes to trig. All right, and we're going to use it to do different things. We're going to use it to find, like if we know sine, how can we find tangent? If we know tangent, how can we find secant? You know, that kind of deal. And these are just rules. I wouldn't say you would have to have them all memorized, but I would have a gist of how they work. Okay. All right. So cosecant of theta is 1 over sine theta. It's the reciprocal of sine theta. And we've talked about that already, how they were reciprocals of one another. And how secant is the reciprocal of cosine theta. And cotangent is the reciprocal of tangent theta. Okay, so they are all reciprocals of one another. And when you introduce the cosecant, secant, and cotangent, we introduce them as reciprocals. The next one is tangent is just sine over cosine. Again, we've talked about that already. Okay, it's just sine over your cosine. And so that means cotangent is cosine over sine of theta. Okay, so those are some rules, the fundamentals, what we've already talked about. All right, these are the Pythagorean identities. They come from the Pythagorean theorem in the unit circle. So remember, with the unit circle, 1 squared plus 1 squared, because sine would be 1 and cosine would be 1, is 1. Okay, and from that, there's the rule that if I subtract 1 or sine squared from 1, I get cosine squared. And vice versa, if I subtract cosine squared from 1, I get sine squared theta. 1 plus tangent squared is secant squared theta. And from that we can say, oh, if we subtract secant squared minus tangent, secant squared theta minus tangent squared theta, we would get 1. And then 1 plus cotangent squared theta is cosecant squared theta. So if I take and I move that cotangent to the other side, I subtract it, I would get 1. So cosecant squared theta minus cotangent squared theta equals 1. All right, so those are your Pythagorean theorem identities, or just Pythagorean identities. Then we have what's called your cofunction identities and your negative angle identities. One note, we're going to talk about with the cofunction identities, we're going to talk about the complements of one another. So we talk about pi over 2. Don't forget, that's just 90 degrees. All right? So the sine of an angle, so let's say the sine of 30, the complement of that would be 60. The sine of 30 is the same as the cosine of 60. So if your complements of one another, your sine is the same as your complement's cosine, and your cosine is the same as your complement's sine. So if I know the cosine of, let's say, 70, it would be the sine of 20. Right? And then cotangent and tangent work that way. So the tangent of 70 will be the cotangent of 20. And then the final identities, we're going to talk about this, and we're going to talk about more identities in a future lesson, is the negative angle identities. So sine of your negative theta. So we think of sine of negative theta is the same as negative sine theta. All right, because when you think about it, we're talking about down here, an angle down here. Sine is negative down there. So if I have a negative angle, sine is negative down there because y is negative. However, the cosine is going to be positive because when I'm down there, all my x's are still positive. But my tangent is going to be negative. Okay, so if sine's negative and cosine's positive, that means tangent has to be negative. So these are all the basic trigonometric identities. Again, you might not have every rule memorized, but I would have a feel for them. Like, I think it's important to know, like, that the sine of an angle is the same as the cosine of its complement. Okay, so that's like an important rule to remember. All right, so the first thing we're going to do is use these rules to find the exact value of each expression. So if I know cosine, how can I find sine? If I know cotangent, how can I find sine? Or if I know of a certain angle, how can I find it? So now we know, if we know any, like sine, cosine, or tangent, how we can find the another trigonometric function of that angle. So first of all, we're going to talk about if we're in quadrant 1. So with these problems, we're from 0 to 90, so everything's positive. Okay, everything's positive in the quadrant, so we don't have to worry about signs of our angles, not the sign. All right, so first it says, if cosine of theta equals 5/13, find the sine of theta. And so what I do is I look at all my identities and I'm like, okay, which one has sine and cosine in it? This one right here. Sine squared theta plus cosine squared theta equals 1. So I'm going to substitute in sine squared theta plus 5/13 squared equals 1. And I'm going to solve this equation. So let's see, sine squared theta plus 25 over 169 equals 1. I'm going to subtract 25 over 169 from both sides. All right, and when I do that, I get sine squared theta equals 144 over 169. I found a common denominator, which is 169. 169 minus 125 is 144. And now that I know what sine squared theta is, I just find the square root of both sides. So sine of theta would be the square root of 144 over 169. Square root of 144 is 12, of 169 is 13. Again, when quadrant 1, everything's positive. I don't need to worry about is it negative or is it positive. So I knew cosine, I wanted to find sine, so I look at my identities. Okay, which one kind of relates those two? And I find it. All right, number 2, they give me cotangent and they want me to find sine. But I'm looking and I don't see one that has cotangent and sine. But I do see one that has cotangent and the reciprocal of sine, which is this one. So what I'm going to do is I'm going to find the cosecant, and since I know the cosecant, I'll just find the reciprocal of that to find the sine. So if you can't find of the Pythagorean identities which one kind of relates those two, then what I'm going to do is maybe find one that relates one guy to its reciprocal, or two reciprocals together. Oops, I left out a theta here. All right, so 1 plus 1/2 squared equals cosecant theta squared. This is 1 plus 1/4 equals that is a 2, not a C. Cosecant squared theta. That's 5 over 4. I'm going to add those together. All right, so then I'm going to find the square root. The square root of 5 over 4 equals cosecant I just want to keep leaving that C out. Equals cosecant theta, so I'm doing the square root of that. So I get the square root of 5 over 2. Square root of 5 can't be simplified. And now I want the reciprocal. Sine of theta equals 1 over cosecant theta. So sine of theta is going to be the reciprocal. So 2 over the square roots of 5. In math, we don't leave a square root on the bottom, so I'm going to rationalize, multiplying top and bottom on the square root of 5, and I get 2 square roots of 5 over 5. All right, so now let's do this in other quadrants. So let's see what happens when we're in other quadrants. All right, so now let's talk about when we're between 180 degrees and 270. So now we're talking about this quadrant here, quadrant 3, 170. In this quadrant, x and y are negative, so sine and cosine are negative. So that means tangent is positive, because a negative divided by negative is a positive. So let's look at question 5. It says, if sine is negative 15 over 17, find secant. Well, I don't know secant, or sorry, there is no identity with sine and secant, but secant's reciprocal is cosine. So I'm going to use that Pythagorean identity again, where sine squared plus cosine squared equals 1. I'm going to do negative 15 over 17 squared. I'm going to add cosine squared theta equals 1. Let's see. This is 225 over 289. All right. And now I'm going to subtract 225 from both sides. Or 225 over 289 from both sides. And I get 289 with our common denominator. 289 minus 25 is 64 over 289. Cosine of theta will be the square root of that. So I get 8 over 17. All right. I need to worry about the sign, or if it's negative or positive. And if I look in this quadrant, cosine is negative. All right, so cosine is negative. So it's negative 18 over, or sorry, negative 8 over 17. And then secant is the reciprocal of that, which is negative 17 over 8. All right, so again, find the identity that works. Sometimes you have to use the reciprocal. All right, let's look at the next example. It says find cotangent of theta if we know cosecant is negative 3/2. Oh, and there is a formula for that. We don't have to worry about a reciprocal. Whoops. Okay, cotangent and cosecant. So I'm going to do 1 plus cotangent squared theta equals negative 3/2 squared. 1 plus cotangent of theta, cotangent there, square root of theta. 9 over 4, subtract 1. 4 over 4, so that's 5/4. So that means cotangent is going to be the square root of 5 over 4, which equals the square root of 5 over 2. If tangent is positive, cotangent is positive because they're reciprocals. And you don't change your sign when you do a reciprocal. So the answer is 5 over 2. All right, so now we're in quadrant, let's see, we're in quadrant 4 with these examples, 270 to 360 degrees. Here, sine is negative, cosine is positive, so cotangent would be negative, but we're going to put it in tangent, is negative, okay? Remember, wherever x is positive, cosine is positive. Wherever y is negative, sorry, let me say that again. Sine matches your y's and cosine matches your x's when it comes to what sign you're going to use. All right, so let's look at this one. We have cosine equals 3 over 10. Find cotangent. All right, so let me look at my identities. I do know that cotangent equals cosine over sine. So if I can find cosine, I can just write it over sine, and then I'll get my cotangent. Or I could even, we could also for this one, 1 plus tangent squared equals secant squared theta. So what I could do as well is use use reciprocal cosine for secant squared theta, and then reciprocal once I get my answer. But I think what I'm going to do is go ahead and find sine, and then put cosine over sine. So this is what I'm going to do. I know cotangent theta equals cosine theta over sine theta. So I'm going to find sine theta to complete that formula or equation, or identity, if you will. All right, so sine squared theta plus cosine squared theta equals 1. Sine squared theta equals plus 3 over 10 squared equals 1. Sine squared theta plus 9 over 100 equals 1. I'm going to subtract 9 over 100. Common denominator will be 100. 100 minus 9 is 91. That just seems weird. I had to double check my work on that one. All right, so that means sine of theta is the square root of 91 over 100, which is square root of 91 over 10. There isn't a perfect square that goes into 91, so that's simplified. So cotangent, is going to be the cosine I got, 3 over 10, over the sine. Oh, do you know what I forgot to do? I got to go back and look at the sine. Sine is negative. Whew, would have gotten that wrong. All right, in this quadrant, sine is negative. So I got sine, but I forgot to pick the sign for my sine, if you will. All right, negative 9 over 10. Oh, negative square root of 91 over 10, excuse me. All right, so to do this, it's going to be 3 over 10 times the reciprocal. That's how you divide fractions. 10s cancel out. So I get 3 over the square root of, or the negative square root of 91. And we're going to rationalize, and I'm going to bring the negative to the top. Okay, so that is an ugly answer, but that's the right answer. Again, was there another way to do it? I could use a different formula and use some reciprocals again. All right, so look at your identities, see which one makes sense to you, and use that. All right. If cosecant theta equals negative 8, find secant. All right, find secant. So let's look at our identities again. All right, so if cosecant equals negative 8. So we know cosecant and we want to find secant. So let's see. If I can find cosine, I can find my secant. So is there cosecant and sine? You know what I'm going to use? This guy again. This guy might be my favorite identity. All right. And I know that cosecant is the reciprocal of sine. So what I'm going to do is I'm going to do the reciprocal of negative 8, and I'm going to square it. I think the reason why I use this identity the most, because I have memorized that sine squared theta plus cosine squared theta equals 1. I've had it memorized since the 90s. So I guess it's what works for you. All right, I'm going to subtract 1 over 64 to get cosine squared theta. The common denominator will be 64. 64 minus 1 is 63. All right, and then I'm going to do the square root of both sides. So cosine squared theta equals the square root of 63 over 64. Let me make that square root bigger. Which equals square root of 63 over 8. You know what? Square root of 63 has a perfect square that goes into 9. So I'm going to take that out. Square root of 9, square root of 7 over 8. So 3 square roots of 7 over 8. And I got to pick the sign. Cosine's positive, so we're good. And then I'm going to do the reciprocal. All right, secant theta equals 8 over 3 square roots of 7. I got to rationalize. I'm going to multiply by the square root of 7, top and bottom. 8 square roots of 7, and this would be 3 times 7, which is 21. Perfection. Was there another identity I could use? Yeah. I could do 1 plus cotangent squared theta equals cosecant and go from there. But I just think, figure out what works for you and choose the best one. All right. So when we're doing problems like this, first of all, make sure you check to see what quadrant you're in so your signs for your answer can be correct. Look at the one they gave you and look at the one you have to find and find an identity or identities that will work for you, that'll help you find what you're missing. All right, the other thing we can do with identities is simplify expressions. And our goal for these is we start out with 2 or more trigonometric ratios, and we want to simplify down to 1. That one can be squared or whatever, but we want just one trigonometric ratio when we're done. So for instance, number 11 has cosecant and tangent. Okay, has cosecant and tangent. And I want to simplify that. This is my little trick to simplifying. So the trick is put everything in terms of sine and cosine if you can and cancel things out. So what I mean by that, cosecant, in terms of sine or cosine, that's the reciprocal of sine. Tangent, in terms of sine and cosine, is sine over cosine. Now that I look, I'm like, oh, I can cancel the sines, and I get 1 over cosine theta, which is secant theta. All right, so get everything in terms of sine and cosine and cancel anything out you can. Or maybe there's a trigonometric identity that pops up, and you go from there. So let's look at 12. This one's already in terms of sine and cosine. Tangent, and I'm going to, would square theta is the same as sine squared theta over cosine squared theta, because I can separate that out. Tangent squared theta is the same as sine over cosine times sine over cosine. All right. And I'm going to multiply times the reciprocal. And look at there. Those cancel. And my answer is cosine squared theta. So again, this is what we're doing. We're putting everything in terms of sine and cosine and seeing what we can cancel. That's how you can make your life a little bit easier. Now, there are exceptions to that. I think there's one at the very bottom of these notes where we get to there, but we'll cross that bridge when it happens. All right, so here's this one. This one's always already in terms of sine. This one is not. All right, so I'm going to put it in terms of sine and cosine. Again, cancel, cancel. There's my answer. I'm just left with this. Again, we're simplifying. We're trying to get just one trigonometric function. So here, number 11, I started with cosecant and tangent. I ended up with secant. Number 12, I had sine squared over tangent squared. I made that to just cosine squared. 13, I had two of them. I narrowed it down. Okay? So let's look at number 14. Oh, you know what? Number 14 is a trigonometric identity. If we go back and look at our notes, cosine squared theta plus 1 is just cosecant squared theta. All right, that's just an identity. So check to see, I guess maybe step 1 should be, is this an identity? Is this an identity? So for instance, on number 15, if we look, cosine squared theta minus cotangent squared theta, we already put in our notes, equals 1. And then 1 minus cosine squared theta is sine squared theta. We wrote that down in our notes. So I guess we're going to add a first step. Before we put things in terms of sine and cosine, we're going to see, is that an actual identity what I'm looking at? Which it was. And then 1 over sine squared theta is just cosecant squared theta. Okay. All right, so let's look at number 16. Neither one of those are identities. So I'm going to put this in terms of sine and cosine. So cosecant is 1 over sine theta minus sine theta all over cosine theta. All right, let's simplify the top. Okay, we need to simplify the top, so we need a common denominator to subtract those. All right, so if we think about it, that's just over 1. All right, so the common denominator for those two would be sine theta. So I multiply top and bottom by sine theta, so I'm going to rewrite that. 1 sine theta minus sine theta times sine theta is sine squared theta over sine theta. Now they have a common denominator all over cosine theta. All right, so now I have 1 minus sine squared theta. Ooh, that's an identity. All over sine theta, all over cosine theta. All right, 1 minus sine squared theta is cosine squared theta. Over sine theta, all over cosine theta. All right, so this is what I'm going to do. I'm going to come up here. Bloop, 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 bloop. All right, so cosine squared theta over sine theta, and I'm going to times that by the reciprocal of cosine theta, which is 1 over cosine squared theta. So I took the bottom of my complex fraction, my denominator of my complex fraction. I shouldn't say bottom, so use fancy words. All right, now I'm going to cancel. So, whoops, nope, this should just be sine, not cosine squared. Give me a second. All right, this cosine is going to make this cosine theta instead of cosine squared theta. So time this right hand side will just be 1, so I'm left with just cosine theta over sine theta which is dun 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 dun, cotangent theta. So let's go through that. That was a really ugly one. So I looked at it when I first started the problem, and I noticed there were no identities. Like 14 and 15, I was like, oh, there's some identities there, and I went from there. But for 16, there is no identity. So since there's no identities right away, smacking me in the face, I put everything in terms of sine and cosine. So I made cosecant 1 over sine, and then I had minus sine theta all over cosine theta. To subtract 1 over sine minus sine, I need a common denominator, which was sine theta, multiply top and bottom by sine theta. So that gave me 1 minus sine squared theta all over sine theta. 1 minus sine squared theta is an identity, cosine squared theta. So once I got there, I multiplied by the reciprocal of my denominator, canceled out, and I was left with cosine theta over sine theta, cotangent theta. All right, so let's look at number 17. I don't see none of that's not an identity, so there's no identities there. So what I'm going to do is I'm going to put everything in terms of sine and cosine. So I get sine theta plus cosine theta, and then cotangent is cosine theta over sine theta. I'm going to go ahead and multiply those two together. So it's going to be cosine squared theta over sine theta. I want to add those together, so I need a common denominator. All right, that's over 1. So I'm going to multiply top and bottom of this guy by sine theta. So their common denominator will be sine theta. So I get sine squared theta over sine theta plus cosine squared theta over sine theta. There it is. There's my trigonometric identity. Cosine squared theta all over sine theta. Sine squared theta plus cosine squared theta is 1. And 1 over sine is cosecant. Awesome sauce. So again, there was no identity, so I put everything in terms of sine and cosine right away. All right, 18 is a brute, but we're going to do it. Right? It's a brute, but we're going to do it. In fact, I'm going to give him his due space. All right. So I look, and there's no identities. I see 1 minus sine theta, but it has to be 1 minus sine squared theta to really help me out. Everything's already in terms of sine and cosine, so I'm going to get a common denominator. The denominator of the first guy is 1 minus sine theta. Of the second guy is 1 plus sine theta. So my common denominator is going to be 1 plus sine theta and 1 minus. 1 plus and 1 minus of sine theta. So this one I'm going to multiply top and bottom by 1 minus sine theta. This guy is going to be multiplied by 1 plus sine theta. Okay. So what do I have? I'm going to write this all out. So cosine theta times 1 plus sine theta. All right, on this side, I'm going to have minus cosine theta times 1 minus sine theta. And they're all going to be over that common denominator of 1 plus sine theta, 1 minus sine theta. All right, look at that ugly thing. Let's simplify it. All right, so on the top, I'm going to distribute this cosine. So I'm going to have cosine theta times 1 plus cosine theta times sine theta. Then I'm going to distribute, this is going to be minus cosine theta times 1. And then a negative times a negative is going to make that a plus cosine theta sine theta. So that's the top. I just distributed the cosine here and here, this cosine here and here. On the bottom, if you can remember from Algebra 2, a difference of squares. See how these are exact same except for you have a plus and a minus? So when you multiply those, I could distribute twice, but it's just going to be 1 minus, okay, that's 1 squared, minus sine squared when I multiply those. Could go ahead and do 1 times 1 times negative sine theta times 1, sine times negative sine theta, and that's what you would get once you simplify. But it's like a difference of squares. All right, let's keep simplifying. Cosine theta would cancel that out. All right, cosine theta would cancel that out. So those cosine thetas go away. I have a cosine theta sine theta plus another one. So I have 2 cosine thetas sine thetas when I add those together. All over 1 minus sine squared theta, cosine squared theta. All right, let's do some more canceling. This will make that just a 1. So I'm left with 2 sine theta over cosine theta, sine over cosine, tangent, so 2 tangent over theta. Woo! That is a brute. Look at that ugly thing, it's just 2 tangent theta. So everything was already in terms of sine and cosine. There was no obvious identities already there. So I had to find a common denominator, simplified after adding those common denominators, noticed the difference of squares, and I also noticed that that was that identity, so it became cosine squared theta. And then on the top, when I simplified it, the cosines canceled out. I ended up with 2 cosine and sines. And then the cosines canceled out in the next step. Sine over cosine is tangent. All right, we're going to make one little change. This has a little bit of a mistake. This should say plus. Okay, we're going to go from there. All right, so what we're going to do, again, I like to put everything in terms of sine and cosine. So secant would be 1 over cosine squared theta over cosine squared theta. Oh, well, those cancel. And that's going to be 1. Well, you know what? 1 plus tangent squared theta is just secant squared theta. That's an identity. All right? That's just an identity. So there we go. I mean, I could have put sine over cosine and changed it from there, but I just noticed, hey, that now I have an identity. So again, see if you can find an identity right away. If you can't, then put in sine and cosine and then simplify from there. Remember, ask me any questions you may have.